Lesson 2-6, Special Functions, Part 2. In the first part, we talked about greatest integer functions, constant functions, and the identity function. Today, we're going to graph absolute value functions and piecewise functions. So the absolute value function, when you graph it, it looks like a V. These are very easy to identify. The absolute function can also be written as a piecewise function, and here's your definition. A piecewise function is written using two or more expressions. Here's the piecewise function for the absolute value of x. The absolute value of x equals negative x when x is less than 0 and positive x when x is greater than or equal to 0. Let me show you how to graph these two. By the way, you could also use a graphing calculator to graph these, but today we're going to try to do it by hand. So in example 3, we want to graph f of x equals the absolute value of x plus 1, and g of x equals the absolute value of x minus 2 on the same coordinate plane. Then we're going to identify the domain and range for each graph. Okay, so the first one, the absolute value of x plus 1. I'm going to kind of create a chart over here, table, where I can plug in some x values. I'm going to plug in the same x values for f and g so that I can graph both of them on the same graph. Okay, so I'm just going to pick the standard -2, -1, 0, 1, and 2 for my x values. That way I'll have some negative and some positive values. If I plug in -2 into the f function, the absolute value of -2 is +2. Then I'm going to add 1 and I'll get 3. I'm just going to fill in the f column first. If I plug in -1, the absolute value of -1 is +1, and then I'm going to add 1 and I get 2. When I plug in 0 for x into the f function, the absolute value of 0 is 0. Add 1 and I get 1. If I plug in +1, the absolute value of 1 is 1, and then I'm going to add 1 and I get 2. And then I'm going to plug in +2 for x. The absolute value of 2 is 2. 2 plus 1 is 3. You can kind of see how a V shape is going to be formed here. Okay, so I'm going to graph f first. Here are my ordered pairs. -2, 3. -1, 2. 0, 1. 1, 2. 2, 3. Okay, so this V is centered at 0, 1. It's going to go up like this forever to the right and up like this forever to the left here. It is perfectly symmetrical, V-shaped, and this one happens to be centered on 0. Let's plug in some values and see what we get for g. I'm going to use the same 5x values. So the first one is -2. If I plug in -2, the absolute value of -2 is 2, and 2 minus 2 gives me 0. If I plug in -1 for x, the absolute value of -1 is 1, and 1 minus 2 is -1. I'm going to plug in 0 for x. 0 minus 2 is -2. I'm going to plug in 1 for x. The absolute value of 1 is 1. 1 minus 2 is -1. And when I plug in 2, I get 2 minus 2, which is 0. And so you're going to see a pattern in the x values, I guess, as long as you know where the center of the graph is. Okay, so let's graph this one. Again, I'm expecting to see a V shape because it is an absolute value function. So when x is -2, I'm sorry, g was 0. When x is -1, g was -1. When x is 0, g was -2. When x is 1, we've got -1, and then we've got +2, 0. So the parent function here would be the absolute value of x. And notice that in f, when I added 1, all that happened was the V got shifted up 1 unit. And in G, we subtracted 2, and it's the same V shape, just all of the points shifted down 2 units from the origin. So that's kind of something to be aware of as well. Okay, so let's identify domain and range for each graph. I'm going to do the f function first, so the top graph here. The domain is all reals. -∞ to +∞. written in interval notation. It's going to go to negative infinity and positive infinity. The range values, however, just for this graph, the y values start at a y value of 1, and they're going to go up to positive infinity. So the range is including 1, so use a bracket, to positive infinity. There's that one. I'm going to do the lower graph, domain and range down here. The domain, again, is all reals. It always is for absolute value functions. And the range, you need to figure out where your y values start. We'll look at the y-axis. Our y values are starting at -2. That's the lowest y value. And they're going to keep increasing. And so it's from -2, including -2, to positive infinity for domain and range. There we go. That one's done. Okay, so these examples, I know this is not quite example 4 on this video, but they pick up from the last video. We're going to graph this piecewise function. This is not an absolute value function, so it's going to look a little different. After we graph it, we'll write the domain and the range. Okay, so a piecewise function has different pieces to the graph. This one has 2 pieces, but just so you know, there could be 3 or 4 or however many pieces of the graph that you want. Also, the other thing that you're going to notice are these parameters. The first part of the function is x minus 4 when x is less than 2. The next part of the graph is just the constant function 1, and that's when x is greater than or equal to 2. And so all of the range values here will be covered. However, there's going to be a split in the graph at 2. Okay, so let me show you what it looks like. When x is less than 2, we're going to graph x minus 4. And so let me give you some table values here. This is for x minus 4, okay? X is less than 2. So I need x values like -1, 0, 1, and anything up to 2, but we're not going to include that point. But I have to make sure that I go up to 2. To show that it's not included, we'll just use an empty circle or an open circle there. Okay, so if I just try these 4 x values, here are my y values. -1 minus 4 gives me -5. I'm only paying attention to the x minus 4 piece right now. 0 minus 4 is -4. 1 minus 4 is -3. 2 minus 4 is -2. So I've got these values when x is less than 2. Okay, this is the first part I'm graphing. Here are my values. Okay, -1, -5, 0, -4, 1, -3, and then 2, -2. This needs to be an open circle because look at our inequality sign. X is strictly less than 2, and so I don't want to include a point for this graph here. So I'll leave it open, but anything to the left here is on the line, so my line's going to keep going to the left of 2. That's the first piece of the graph, okay? So now I'm done with that part, and I'm going to graph the next part. This says f of x equals 1. It's a constant function 1 when x is greater than or equal to 2. This one's so easy that you don't really need to make a table, but let me just show you what it is. So this one says y equals 1, basically. So anytime x is greater than or equal to 2, so that would be for values like 2, 3, and 4. The y value is always 1. It's a constant function. Remember, it's going to be horizontal. So when x is 2, y is 1. This point is included. Look at your symbol. It's equal to at this point. So I'm going to fill in my circle there for 2, 1, 3, 1, 4, 1, 5, 1, and so forth. This piece of the graph is a horizontal line going to the right, but only for values that are greater than or equal to 2. And so here's the 2 pieces of the graph. It splits at 2. Everything to the left of 2 is x minus 4. Everything to the right of 2, including 2, is the function y equals 1. This is a piecewise graph. You've got kind of separate functions here to graph, and the graphs will have separate parts. So the hard part now is writing the domain and the range. If I think about my domain values, how far left and right my graph stretches, I'm looking for x values here. All of the x values are covered. Even though there's a jump in the graph, all of these x values are covered. Even 2 is covered. and then everything to the right of it. So the domain here is all reals. Negative infinity to positive infinity. The range values, however, there's a skip here. For the range values, you want to look at the y values, so up and down, how low and how high does your graph go? Well, on the bottom side here, the y values will reach negative infinity. But for this piece, they happen to stop at a y value of -2. And that value is not included, so I'm going to use a parenthesis. Now, I need to make a union sign here because there is another piece to the graph. The y values in between here are skipped over and pick back up at y equals 1. And that's the only y value that we have left in our domain. And so the range values go from negative infinity until we get to -2, and then just 1. And there's no interval here, it's just the number 1. Okay, here we go. Take a minute to look at that domain and range and really understand it. Okay, I'm going to try one more with you before I let you try them on your own. If you look at this function g of x, it's a piecewise function again with two pieces. The functions are x plus 2 and x. And remember, you can think of these as y equals x plus 2 and y equals x. Now the graph is going to split at 0. I've got this graph, this line when x is less than 0, and I've got the line y equals x when x is greater than or equal to 0. So I'm going to graph the top one first, y equals x plus 2. Again, if you're making a table for y equals x plus 2, you want to look at your parameters. The function is set up so that the line x plus 2 only exists when x is less than 0. So when I plug in values, I want to pick -2, -1, and 0, keeping in mind that 0 is going to be an open circle. Okay, so if I plug in -2 into this function, -2 plus 2 is 0, -1 plus 2 is 1, and 0 plus 2 is 2. So I'll put these points on there. -2, 0, -1, 1, and 0, 2, but I'm remembering that this x value has an open dot on it. Okay, and so I got this line going down forever and ever and ever, so I'll put an arrow at the end of it. Okay, that's the first part of the graph, first piece. Now I need to graph y equals x, and ask yourself, where does this function exist? This function exists when x is greater than or equal to 0, and so if you would make a table, or even if you know how to draw on the line, you only want to include x values that are bigger than or equal to 0, so like 0, 1, and 2. If I plug in 0, I get 0, y equals 0. When I plug in 1, I get y equals 1, and when I plug in 2, I get 2. It's the identity function, y equals x, and so x and y will always match. Okay, so here's this graph. 0, 0, closed dot here because 0 is included on this function. 1, 1, 2, 2, 3, 3. This graph is going to increase up to the right like so. Okay, so here's my piecewise function. I've got x plus 2 to the left of 0, and I've got y equals x to the right of 0. Again, keeping in mind my endpoints. Closed dot on this one, open dot on this one. Let's write our domain and range, and we'll be done. The domain is all reals. Every single x value is covered on this graph. Let's think about the range values here. The range values are the y values. Now don't limit yourself just to the y-axis, otherwise you might think that there's a jump here. You have to think about what y values are on the graph. Well, this piece here is definitely going to negative infinity. This piece is going to positive infinity. There's really nothing skipped in between. If I trace along here, all of these y values are hit. All of these y values are hit. Some of them are even hit twice, like the y value 0 or the y value 1. And so the range here is also all real numbers, negative infinity to positive infinity. There's not a single y value that's skipped over. All right. Please try this last graph on your own. These are pretty difficult, but try it out and see how you do with it.